All right, let's take a peek at our last section that we're going to do here. Multiplying polynomials again, but these are going to be slightly more advanced. So let's take a peek. Practice, fill in the blanks to complete the steps, and here's our steps for multiplying two polynomials. Step 1, use the terms in one polynomial to label the columns, one term per column, and then label the rows with the terms in the other polynomial. Multiply each column by each row and then label to fill in all the entries. Add all the products and then simplify the sum. That's where we combine any like terms if possible. Okay, so let's take a look. Here's an example of a trinomial times a binomial. Notice that we listed out the two terms here on the side already from the first binomial, and the trinomial is listed here. These are all positive terms, and if there were negatives, the negatives would be listed with these items. So here I go. X squared times 3x squared, coefficient times coefficient, and then x squared times x squared. 4 times 1, x to the third, 8x squared, 9x to the third, 12x squared, and 24x. And then we're looking to combine like terms. So for example, these are x to the thirds, and these are x to the thirds, so we can combine that. And these are x squareds, and these are x squareds, so we can combine that. If the term has nothing else to combine with it, we just write it. We're going to also write these in descending order. So 3x to the fourth goes first. 9 plus 4 is 13x to the third. 12 plus 8 is 20x squareds plus 24x. Notice that we are only adding the coefficients in front, and it's how many x to the thirds are there. The x to the third stays the same in the answer. This right here is a result of adding these two like terms, and this right here is a result of adding those like terms. All right, let's try another one with negatives. All right, so here we go, already listed out for us. X squared times 2x squared will be 2x to the fourth, x to the third, negative 3x squared, negative 2x squared, negative 1x, and negative times a negative is a positive. Now notice this time that these are the only like terms. So here I go writing the product, 2x to the fourth plus x to the third minus 5x squared minus 1x plus 3. And this right here is the result of combining the two like terms. Everything else just was an individual term. All right, so how to use the distributive property to multiply polynomials. So if we don't want to use this box. So distribute the first polynomial over the second one. Use the distributive property on similar products, and then collect like terms and simplify the answer. So this x squared is going to go to everything back here. So for example, we would say 3x squared plus 4x plus 8 all times the x squared. And then we would say the entire thing again, all times the back of 3x. So each term has to go to everything. Now here we go. X squared times 3x squared would be our first multiplication. X squared times 4x. And then x squared times 8. these three products are just multiplying through by the first section. Now let's go do the back section. 3x times 3x squared. Three x times 4x. And finally, 3x times 8. So now these are what we're multiplying, and so we can now start simplifying and then combining like terms. So the coefficient times the coefficient, x squared times x squared. Notice that these x to the thirds go with these x to the thirds. And then notice that these x squareds go with these x squareds. So final result, once we combine like terms, now if you notice, this was the exact same problem as the first one we did over in the practice. We just used the other method, distribution or grouping, versus the box method. So which way are you leaning towards? Which one do you like? All right, down here, let's fill in the blanks. Multiply, we're looking how to multiply binomials vertically. So step 1, make sure both binomials are written in descending order. They have to be in order before you get started on this method. Okay, and then set up the problem vertically with the factors that are aligned with like terms. Now we're going to multiply each term on the top binomial by the last term of the bottom binomial. Multiply each term of the top binomial by the first term in the bottom binomial. Finally, add the two smaller products and simplify. This is again where we combine the like terms. So here it is set up vertically for you to see how you like this method. So we're multiplying this time. We're going to multiply each term in the top by the last term of the bottom, and then we're going to multiply each term of the top by the first term. So here I go. 6 times 2 makes 12. 2 times 2x makes 4x. And 2x squared. Now we're doing this last one and we're lining up like terms. So 5x squared times 6 is going to be 30x squared, 10x to the third, and then 5x to the fourth. And then we go ahead and combine like terms vertically, adding 12, 4x, 32x squared, 10x to the third, and 5x to the fourth. There's my final answer. So let's try one more, doing this vertically. Negative 3 times 4 makes negative 12, negative 9x, and negative 6x squared. Notice I'm writing these in descending order. Now here I go with 16x squared, 12x to the third, and 8x to the fourth. Notice I've lined these up with like terms. These have nothing to combine. This makes 10x squared because we subtract and keep the sign of the larger. And there's my final answer. All right, I can use the same methods to multiply both. I can use a table, I can use the distributive property, or I could use vertical arrangement. I called this the box method. I have to multiply more terms when I multiply trinomials. For trinomials, I have to add 3 partial products instead of 2. I can use FOIL for binomials, but not for trinomials. Next is to find the product and show your work. So we're using the vertical method on this last example. So 2 times 1 . Okay, writing these in descending order, putting the like terms under the like terms. And then the last one. And then I add vertically. So here I have positive 10x squared and minus 12, resulting in negative 2x squared. Here I'm going to have 7x to the third, and nothing to combine with that last one. How'd you do?